Okay, good afternoon, guys. See, today, I just want to do about 2 questions from the assignment 2 problems. Guess I'll say questions 5 and 6 from assignment 2. If you have any other questions you want to go over, we can do those instead. Just I see there's someone in the. Okay, yeah. Good afternoon. Okay. Yeah, if you have a question you'd rather do, please suggest that. Okay, and then just in the second half of class, we'll just talk about these terms, like maximal elements, upper bound, least upper bound, all that nice stuff. Okay. Okay. So we'll just say like least upper bounds versus maximal elements. So that means we're talking about more about partial orders like less than or equal to. Okay, so let's start with question 5. Question 5 says, A and B are sets. And then you put B to the A to be the set of all functions from A to B. And we're supposed to prove B to the A is a set. Meaning we have to use like the axioms. We have to construct it from other sets and then use the axiom schema of comprehension. Okay. Okay. So here's our strategy for these things is find a set X such that all functions from A to B have F or elements of X. And then our second step would be then use axiom schema of comprehension. Schema. Okay. Because once we have our set X, well, our property is just going to be like P of F is just going to be F is a function. The domain of F equals A, and the range of F is going to be a subset of B. Once we have a set containing all the functions from A to B, we'll use P of this P as our property, and then we get this the set B to the A. Okay, so the trick is, as with all these things, is to find some set which contains all the functions. Okay, so let's try. So yeah, this is a good idea. So in the chat, Joshua has suggested P of A times B. Okay, the power set of A cross B. This is a set because A and B are sets, so we prove the Cartesian product is a set. And the power set of a set is still a set. Okay. Okay. Power set of A cross B is definitely a set. You want to know, is every function from A to B an element of the power set? Well, that's just saying that every function should be a subset of A cross B. Okay. And now if once we try to unravel it, you'll see that this is good. Okay. So A cross B is a set. And so P of A cross B is a set. Now, if F is a function from A to B, then F is a subset of A cross B. So F is an element of the power set of A cross B. So all the functions from A to B are elements of this set. So now B to the A is just the elements of the power set of A cross B such that their functions, F is a function, the domain of F equals A, and the range of F is a subset of B. And if we wanted to, we could expand what it means to be a function. We would just put that for all A, if A and A comma B and A comma B prime are both in F, then B equals B prime. But they'll just leave it like F is a function. Okay, so this proves that B to the A is a set. Oh yeah, I guess we should say by axiom schema of comprehension. B to the A is a set. Okay, and that's the end. So it wasn't too bad. Let's try question 6, which is more of an example. Okay. Oh, wait, I forgot to ask, did anyone have any questions before I go on to question 6? Okay, well, okay, let's go on to question 6. Okay. So question 6 says X has two elements. One element is the empty set, and the other element is the singleton of the empty set. And then Y is going to be the power set of X. If you remember, so the power set will have four elements. Okay, actually we might as well write it out. Well, you have the empty set as a subset of X. The singleton containing the empty set as a subset of is an element of the power set of X, right? This is because this is because of this, for this reason. Okay. And then we have all of X. Okay, so here are my four elements of the power set of X. You'll notice that actually Y intersects, like Y has some elements in common with X, which is, I guess, it's maybe interesting or maybe not interesting. That's fine. Oops, I went over the border a little bit too much. Okay, so this is our set Y, this is our set X. And then we have to describe membership relation on Y and the identity relation on Y. Oh yeah, and then it says determine the domain, range, and field of both relations. Okay, before we do that, I'll just remind you what is the membership relation on Y. Okay, I'll just write it like this. A is a member of B if and only if A and B are both in Y and A is an element of B. And the identity relation is that A related to B if and only if A equals B. And A and B are both in Y. Why? Well, to write these things down, we just need to go back to the actual definition for identity relation and membership relation. Maybe it's worthwhile for me to write those two things down. So let me flip this page. Okay. The identity relation on Y is a set of all ordered pairs A comma A such that A is in Y. Okay. So that means that A is related to B if and only if A/B is in the identity relation. And the only elements in the identity relation are just A comma A. So that's true if and only if AB equals, I'll put it like this. C comma C for some C, which is true if and only if A equals C and B equals C. In other words, A equals B. Oh, and I went too far. Again, let me just try and draw a border. There. Okay, but I'll just scroll over a little bit so you can see the edge, right? So this tells us that by defining the identity relation to be all the ordered pairs whose first and second coordinates are equal, that tells us that A is related to B if and only if A equals B. Okay, and of course we need the assumption that A and B are both in Y. So this identity relation on Y is just equality of things in Y. Okay. So if we want to describe it, we would say identity is equality of elements in Y. That's how I would describe it. You might use slightly different words, but I think that would be okay too. Okay. Now we need to figure out what is the domain, range, and field. Well, the domain of the identity relation is all of Y. The range of the identity relation is all of Y. The field is also Y. Well, it's just a union of the domain and range. Okay, so that's pretty straightforward. Remember, the domain is just a set of things which are a first coordinate in the relation, and that's everything in Y. And the range is the set of things which are the second coordinate of something in the relation, and that's also all of Y. Okay, so I think we have completely described the identity relation. Actually, we could also write it down. But it is, yeah, I won't do that here. Okay, so let's move on to the membership relation. Let me first at the very top, I'll write down what is X and Y again. Okay. Okay, it's better now. And then let me remind you what is the membership relation. Well, it's all the ordered pairs A and B such that A is an element of B and A and B are in Y. Okay. So let me write down Y again. Okay. So it describes membership. So let's see. One thing we can write down, like notice. The empty set is a member of the set which contains the empty set. Now, since these are both elements of Y, we just put this. Okay. Okay. What else is the empty set a member of? It is also a member of this third set, the all of X. Notice it is not an element of this set. Okay, now let's write all the things which the singleton is an element of. Well, it's both an element of this and this. Right? This singleton is a singleton whose only element is this one. And it's also an element of X. Here it is. Okay. Okay. And that's all the things that are related to each other. Like this is not an element of any of the other elements, and neither is this. Okay. So this membership relation has like describes four relations basically. The empty set is an element of these two sets, and the singleton containing the empty set is an element of these two sets, and that's it. Okay, so that lets us describe the domain and the range. The domain of the membership relation is, well, things that occur on the left. Okay, the range, well, that's all the things that occur on the right. This, that's a range. And the field is the union of these two. And that is pretty much it for question 6. Okay. Now before we move on, were there any questions about question 6? Or you could also, if there's any question that is proving to be tricky from the assignment, now would be a good time to mention that. Okay. Well, for now then, let's try and finish off this this chapter 2 if we can today. That would be really good if we could. I know the terms we need to talk about are chain, least element, minimal element, lower bound, infimum, and then all of these have to do with like less than or equal to. Well, we also have greatest element, maximal element, upper bound, and supremum. Okay, so let us just take a 5-minute break. And then when we come back, we'll try and I'll try to remind you of all these different terms. Okay. Okay, so I'll end the meeting and then just I'll restart it. And I'll give you, we have about 5 minutes to get going again. Okay.